So, how do we name binary ionic compounds? Well, binary just means a compound made of two different things, and ionic means it's got a cation and an anion. So, cations are normally going to be a metal, so it's going to be anything coming from this left side of the periodic table, and the anion will be formed from a non-metal. So, the way we name them, the convention is to name the metal part, the cation part, and then the non-metal part. So the easy way to remember that is we read from left to right. So the metals are on the left side of the periodic table and the non-metals are on the right side. So you just say the metal name and then the anion name. So that will be the anion element. And then you take off the ending and then just put "ide" on the end. And you probably already do this kind of naturally anyway, like sodium chloride. You know, it's got that "ide" ending. It just sounds right. So if we look here, we've got magnesium, and then this anion is coming from nitrogen here. So that would be magnesium nitride. So let's get with the naming first and then worrying about the empirical formulas. So magnesium nitride would be the name. Now, the empirical formula is going to be the smallest whole number ratio between the cation and the anion. That is going to give me an electrically neutral compound. Okay, ionic compounds should not have a charge associated with them. So if each magnesium is a +2 charge and each nitride is a -3 charge, that sum has to end up as 0. So we've got, if you like to do it algebraically, x times +2 plus y times -3 is equal to 0. So what have x and y got to be? So hopefully you guys can kind of algebra this out to work out that x then must be equal to 3 and then y must be equal to 2. If you're not sure, work it out. So 3 times +2. Oopsie, if I could type, that'd be great. Is 6. And 2 times the -3 charge is going to be -6. +6 minus 6 should sum to 0. So that would give me an electrically neutral compound overall. Okay, so the empirical formula, then we would just use the subscript to say how many magnesiums to how many nitrides we have. So we'd have Mg subscript 3, N subscript 2 for magnesium nitride. Okay, so it looks like it's magnesium all the way down here for our metals. So the only thing that is changing is our anion identity. So oxygen, take off the ending, turn it into an anion name, would just be like "ide." So that would be magnesium oxide. Magnesium oxide. So the formula for that, if magnesium's +2, oxygen's -2, they're going to balance each other out. So it should just be MgO. Magnesium and then phosphorus over here, take off the urus and change it to an "ide" would be magnesium phosphide. If I could type, that'd be great. And then the formula for this would be, you're going to need 3 magnesium 2 pluses to balance 2 phosphide 3 minus, so Mg3P2. And then lastly, S is sulfur, so that would be sulfide, so that would be named magnesium sulfide. So the formula of that, if magnesium is +2 and sulfide is -2, would just be Mg. They would balance each other out. Okay, so let's get another one up just to make sure that we've seen all kinds of possibilities. This one is boring, so I'm going to skip it. This one is similarly boring. As is this one, really. It's pretty much the same as what we've just done. What I'm looking for, and I know I've seen it, is occasionally it will throw in a transition metal like iron or copper or something. I know I've seen it. Should have got that one up first, but you know, I like to work easy to hard. Apparently, ALEKS is not going to help me out with this. Come on, ALEKS, show me one of the harder options on this one. All right, let's give you a few more goes. And I literally just paused the recording and it was the next one that came up. So I sometimes feel like ALEKS is playing a trick on me. Okay, so if I get the periodic table up, you'll see that iron is over here in where our transition metals are. Okay, so see these ones that are like highlighted in yellow here? These are the metals which can have more than one different charge associated with them. So it is very important when you name compounds with iron in them, for instance, anything that's in the middle here, plus things like tin and lead that can either be +2 or +4, that you have to indicate the charge on the metal cation. And the way we do that is using Roman numerals. So if I knock out these two simple ones first, sodium chloride +1 -1 will give me my empirical formula NaCl, and that will just be sodium chloride. So I don't have to use any Roman numerals there. And again, with barium chloride, this time barium is in group 2. It's got a +2 charge, so it's going to need 2 chloride -1 anions to balance that out. So that would just be barium chloride. Chloride. But for iron 2+ and iron 3+, you have to actually say that it's iron 2 or 3+. So if we get the empirical formulas of these, you can see it's going to have two different empirical formulas. So it's completely different compounds with different chemical and physical properties. The iron 3 cation will need 3 chloride ions to balance it out. And the iron 2 will need 2 chloride ions to balance it out, so it's charge neutral. So when we come to name these, we need to specify that it's iron 3 chloride or iron 2 chloride. So you just use Roman numerals in parentheses after the name of the metal, and that will be for any transition metal. So scandium and yttrium tend to only be +3, so they don't really count. But the rest of them, any of these guys in here have got variable charge, plus tin or lead. So you should always indicate the charge with Roman numerals when you're naming those kind of compounds.